Yeah, welcome. My name is JanRosenkranz from Luleå University of Technology. I replace Lisa Malm from Boliden. She's industry or doctoral student in our project. And yeah, I will give an overview on high float. The idea behind high float is that we want to look at different cell geometries of flotation cells. So today there's a trend towards much larger cells, up to 600 cubic meter you have today in volume. And with increasing height, it's of course that there are several parameters that change. So the way of the bubbles and particles up to the surface, to the foam on top is increasing. You have changes in the hydrostatic pressure. You have changes in the distribution of the pulp. And all that is of course affecting separation and separation efficiency within the flotation process. So the idea behind high float was then to do some systematic testing of how different geometries, so particularly different ratios between height and diameter will affect flotation. And this on lab scale, on pilot scale, and on full scale flotation cells. We have varied geometries on lab scale, and otherwise looked at also different aspect ratios of pilot cells in order to improve design routines and also look at different placement of different designs in a larger flotation plant. So this is of course then also fitting the overall objectives of the ZIP stream, so that we try to improve separation, meaning increasing resource efficiency, decreasing losses, and also look at some new developments in terms of equipment. Results, the project has been running since 2014, so we have done quite a lot on different scale already. Results from the lab scale tests. You can see here some selected results. We developed a lab scale flotation cell where you can change the height. Based on a Magoto lab cell, we put several rings and then did tests, batch flotation tests for 20, 30, 40 centimeter height. And you see also some results here in this diagram. The phenomena that we observed were that with increasing height, the recovery decreased while the grades of the concentrate increased. We had finer particles with increasing heights in the concentrate. And we had also different flotation kinetics, as you see the different curves. 1 minute. So, except for that, we did tests on a pilot scale. We used 1 cubic meter cells from Autotech. We changed one of the cells towards a higher height and ran in parallel to the flotation of the IT concentrator plant. So we did in that case tests in the rougher flotation and also sampled not only the products, so the cons and the waste flows, but also within the cells at different heights, in order to get a vertical profile. This same concept taking samples at different heights, we also did on full scale. And here you see one picture that was also in the introduction, taken from ITIC, where we sampled from 160 cubic meter cells. We, in that case, did a campaign with over 100 samples from different cells, so from rougher, from scavenger and cleaner flotation. And we looked at these vertical profiles, as you see in the lower right corner. So looking at the distribution of solid material, looking at the composition at different levels, and also on particle properties. What we now need to do is to evaluate these results with respect to modeling and finding improved design routines. We have had some delay in the evaluation of the pilot scale tests, so that's why we also asked for extension of the project to the end of the year. And in that time we will now do this analytical and more theoretical part.
Okej, tack så mycket Jan.